Hello everyone. In this video, I'll be talking about how one can develop a smart contract for Weilchain, deploy it, and use the Elliptic CLI to interact with its exposed methods. Before going further, what is a Weilchain? A Weilchain is a sharded blockchain built from ground up. It contains what are called as Whale pods. Whale pods are a collection of nodes, which are also called pod members, that runs a DAG-based consensus protocol. There can be as many whale pods as possible inside a whale chain. There is a special kind of whale pod called Senate pod, which has a special stature because of the bookkeeping it does to manage all the other whale pods in the cluster. There is also another kind of node called a sentinel node, which is a layer of indirection used for external clients to interact with the platform. Now, external clients can be Elliptic CLI itself, a browser wallet, or a dApp. A typical smart contract development workflow looks something like starting with a Weidel spec file. Weidel stands for Elliptic Interface Description Language, which is an ideal interface description language we have made to provide developers with a universal syntax and type system to specify the function signatures of their smart contract. And that's what we call as interface. So interface of a smart contract is basically all the exposed methods and their function signatures specified using the Weidel syntax. Weidel not only provides with a language agnostic syntax, where it doesn't matter what language you are using to write your smart contract, for example, Rust or Go, or whatever language you are using to write your dApp. It provides you with a universal language agnostic language to specify your interface, and also gives you the ability to auto-generate a lot of boilerplate code called as bindings for these server or client side program. In this example, we'll see how we can use the Weidel spec file to generate smart contract bindings, fill in the implementation or the business logic of the smart contract, compile it to a WASM module or a WebAssembly module, and then deploy it on chain to a particular whale pod and use the CLI to execute exposed methods of the smart contract. Just a side note here, all the smart contracts of Weilchain are WebAssembly modules. So these are files with .wasm extension. So all the languages we support for smart contract development, their compiler toolchain should target WASM32 unknown target. Now let's get deep into the code. I already have a repo setup called demo. What I'll do is I'll move forward and build a Rust crate called demo1. Open it in my editor. Rearrange some files. Perfect. Now, before moving further, I'll just add a bunch of dependencies to my project. Now, if you observe, some of these dependencies are Rust dependencies like serde, serde.json, or anyhow. But other dependency is this thing called as WhaleRS. So all the languages we support for developers to write their smart contract in for Weilchain, we provide them with a contract SDK framework. For Rust, it's called WhaleRS contract SDK. And that's what we will be using as our dependency. So I have added the dependencies. Now what I'll do is, as I told you, we'll start with writing a Weidel spec file. So I'll name demo1.weidel. I specify my interface like this. Now, before discussing what our smart contract would do, I would like to tell you a bit about what are query methods and what are mutate methods. And Weidel provides you syntax to specify which method it is. So for example, Let's say I have a query method called as getList, in which the signature takes parameter as an ID and returns a result with OK variant to be a list, or error. If it errors, I'll just return an error message. And I have another method called as mutate method, which has signature like this. I'll tell you in a bit what these method signatures signify. But if you observe, we have two methods. One method is a query method and another method is a mutate method. Now, what are the difference between these two? So as I told you, when you deploy a smart contract, you deploy it on a particular whale pod. A whale pod is a collection of nodes, also called as pod members, that runs DAG-based consensus protocol. When you invoke a query method, what you do is basically you choose a pod member at random from the whale pod on which this smart contract is deployed on, and you send the request to that particular pod member, and it makes a local DB call for the contact state and returns the result. So a query method in principle does a persistence call on the local node pod member which is being selected, and it returns the result, and there is no consensus, nothing is involved. Whereas a mutate method is something which involves mutating the contact state, and hence it needs to go through the consensus protocol and executes on all the pod members of that whale pod. So typically a mutate method takes a little bit longer than a query method. Ideally, a query method should only read contact state. That means that it should not have any mutations or changes to the contact state. And a mutate method might contain changes to the contact state. We'll see in a bit what contact state is and what's the significance of mutation and an immutable reading of the contact state. But that's how we define methods in the interface with the annotation of whether it's a query or a mutate. The smart contract we'll be writing for this demo is a simple smart contract which contains a state which has a mapping from a string to a vector of integers, U8. This kind of use case is quite frequent in smart contract development, where you have a mapping which would contain some user identifiers and some vectors. For example, if you are building a chat application, a chat messaging application, what you would have is you would store a hash map which would map user identifiers to the chat they have for their account. Now, we'll start by discussing first what is called as orthogonal persistence. I'll also go deep into what it is and how, using what is called as whale collections, we achieve orthogonal persistence, and also represent these data structures in memory, even though they might span to thousands or millions of users using the smart contract. So before moving further, I would also like to tell you that for the Widal, we have a VS Code extension. So if you use VS Code, you might be interested in downloading this Williptic official extension we have called Widal. So you just search Widal and you can just install the extension, VS Code extension. So yeah, moving forward, what we can do now, I already have Widal compiler on my machine. So what I'll do is I'll do Widal generate demo1 server Rust. And it generates a binding.rs file for me. I'll just copy this to my lib folder. And yeah, this is my smart contract. Now, if you notice, whatever the interface you define is translated to a Rust trait with the native Rust types. So for example, a list in Widal type becomes a Rust vector. or a Widal string data type becomes a Rust native type string. And that's the typical translation which happens within the Widal type system to the language you are targeting. Then you observe that there is also a context state for if in the smart contract. Now this context state is the main state which is persisted on chain. Okay, so its serialized version is persisted on chain, and this is the mental model I would like all the developers to carry with them. Is basically a smart contract is a struct which is basically called as context state, which is persisted on chain, and then the exposed methods are just bounded methods of that state, of that contract state. And these methods might be either query methods, which might contain logic which just reads this contract state, or it might contain a mutation which, as I told you, would be executing on all the pod members of the whale pod and runs through the consensus protocol. But that's the mental model one should have, that a smart contract is a struct which is called as context state, which is persisted on chain, and you have bunch of exposed methods which are nothing but bounded methods of that struct. So I'll move forward and fill in the implementation. So as I told you, we'll have a map called whale map of string vector of u. Now, I told you a bit about orthogonal persistence. One should search what, let's say, orthogonal persistence is. Let me search it. We'll go to Wikipedia, and if I see the official definition, a persistence is said to be orthogonal or transparent when it is implemented as an intrinsic property of the execution environment of a program. So basically, an orthogonal persistent environment does not require any specific action by the programs running it to retrieve or save their state. And within the Williptic Contract SDK framework, we achieve orthogonal persistence through whale collections. So a user or the smart contract developer never have to think about how they would persist a mutation or how they would persist the contract state back to the chain. Okay, they can purely carry a mindset of having these data structures in memory, and we as the SDK providers provide you with the logic of reading the state, serialized state from the persistence from the platform, taking it to the WASM runtime, deserializing it, making it available so that we can call method, whatever method you have invoked on the state, and then if there are any mutations, persist them back to the platform. So all of that is taken care by the SDK itself. And whale collections are really important in achieving orthogonal persistence and scalability. Why I'm saying this? Let's say you have a chat messaging application. The chat messaging application would have something very similar. It would have a map with a user identifier map to the chat allocated to his or her account. The thing is that this contract state containing this map might contain tens of thousands or even millions of entries, right? It would span and scale to the number of users using this smart contract. So a typical chat application might have thousands of users. Now, all the data of those users cannot be residing all in memory, right? You cannot have all of that data in memory. But as I told you, as the framework, we want the developers to think of the data structures to be residing all in memory. So how we achieve that is we provide what are these things called as whale collections, where whale collections provide lightweight, shallow, lazy data structures with the similar kind of APIs mimicking standard library APIs. For example, whale map would have similar APIs like get or insert, like the hash map we have in Rust. We also have whale vec, which would provide get and set APIs similar to standard vector in Rust. And these lightweight data structures, what they do is they hold enough information meta information to load the data structure in memory, while not loading any of the real entries or the entries which is spanning to all those users. And only it loads or sets the entries for a particular key when we access the APIs like get or insert. And that's how we achieve orthogonal persistence and also scale these data structures to a large number of entries. So whale collections are really important in that sense. So, okay. We have the collection here, whale map. Now what I'll do is I'll move forward and start implementing it. So I'll do is I'll use the ID to check if it is available in the map. If it's not there, I'll just return an error saying ID is not present in the map. I'll just write a formatted error message, or if I get the list, I'll just return that list. Yeah, this looks good. Now, one thing I want to tell you at this point is that I told you that these whale collections mimic the standard library APIs, but there are some differences. For example, if we hover on this get API and we see the signature, it returns me an option of the value. And this value is the owned value and not a reference. Now, if you see a standard hash map in Rust, let's say, the get API returns me a reference. Now, this is the difference which one needs to keep in mind, because let's say I have some logic where I access the key get ID, as I'll return the similar error message. Let me rename this variable to list. Yeah. Now this list variable, if you see, is an owned value. It's an owned vec-u8. So if I add any entry in this list, it would not reflect back to the map, which is stored in the context state, because it's an owned value. And Rust ownership type system is depicting that thing. So what you need to do if you want to persist this updated list value back to the map, what you do is you insert it again. You would have ID and you do list. So this line is really important to be added. And yeah, like this, we have a smart contract which uses a whale collection and has a simple two methods. One is a query method called getList, and another is a mutate method, which is setVal. I can also fill in the implementation for the constructor. Open whale map. Now, again, here an important point arises where every whale collection has an associated whale ID with it. And it is absolutely necessary for the developer to keep in mind that for a particular smart contract across all the methods, across the lifetime of the smart contract, statically or dynamically, these whale IDs should be uniquely allocated to the collections. For example, if I would have another field called as whale vec, let's say, vec-u8, and if I define that in constructor, I would use whale ID 1 here or anything, but it should not be 0. So all the whale ID should be unique. And I cannot stress much that it can be catastrophic if anywhere same whale ID is allocated to two different collections across the lifetime. Either the collection is statically defined like this or is dynamically produced. For example, if there is a whale vec as a value and you are producing that value dynamically in some logic, it should always have a unique whale ID. We'll just remove this thing. And yeah, I think our contract looks good. So just to recap what we have done, we basically started with a Vidal spec file. I told you what's the difference between a query and a mutate annotation. A query method selects a pod member at random from the whale pod on which the smart contract is deployed and does a local persistence call for the contract state and returns the result. Whereas a mutate method has to go through the consensus protocol and is executed on all the pod members. Using this Vidal spec file, we generated what are called as server bindings, which are smart contract bindings, and the target language we used was Rust. So it generated an empty bindings for me. Then I went on to fill the business logic for it. And now we can compile the smart contract. I already told you whatever tool chain you are using, you should target your binary to WASM unknown 32. So I've specified the target as WASM 32 unknown unknown, which would give me a .wasm module, also called as WASM module. So all our smart contracts of the Weilchain are WASM modules. If you want to see that WASM module, you might go in WASM 32 unknown unknown release, and you can see the .wasm file. Perfect. So I think this looks good. What I'll do is, let me reset. Let me add git ignore file. Target. So I'll add these files. And we'll check this scheme. Perfect. Now I have my multipass instance, which is running the local testnet, also called as Finish, for Weilchain, running in my multipass instance. I also have the demo repo setup. So what I'll do is I'll take the pull of the demo repo and I'll build it here as well. Perfect. It got built. Now, if you observe, I would have inside targets my demo.wasm file. I'll just copy this path. This will be required while deploying the smart contract. So I'll just keep it aside, demo1.wasm. I would also need a Vidal file. So I'll also copy its path. Demo1.Vidal. Perfect. Before going any further, let's revisit the smart contract we wrote. One change I would like to make here is basically when we set the value, if the ID is not there, what I'll do is instead of returning a error, what I should do is I should insert that particular key in the map. So I would do ID and the value would be vector of val. And I'll also just return like this. I'll just change signature a bit. Also change the Vidal file. I can regenerate. Can regenerate the trait. Let's replace it with the lib. Yes. Okay. So yeah, I think this looks good. While getting the list, if the ID is not there, we just return the result. While setting the value, if the ID is not there, we would insert that particular key with that value and return. Or if the list is already there, we would get in the list, we would push the new value, and then we would insert back to the map because it's an own value. If you observe, there is nowhere in the interaction with the whale map you would have to worry about persistence. And that's the power of orthogonal persistence and whale collection, is that you don't have to worry about how you would be persisting your mutations, or whether if this whale map spans over millions of entries, how it's going to be fit in memory. Nothing of that sort. It's all taken care by the whale collection's internal implementation, and that's how we achieve orthogonal persistence. It's similar to how ORMs work in database world. Okay, so I think this contract looks good to me. What I'll do is, yeah, what I'll do is I'll check these files in these changes which I made and fix. Perfect. I'll take the pull and rebuild it. Perfect. We have already saved the files. The files would be same. Now we'll move forward and use the local testnet panache and use the Elliptic CLI to deploy the smart contract and interact with it. Okay, so I'll run my CLI. Perfect. Now, in the docs of how you set up the Elliptic CLI, you would know that you would need a private key setup on your system, and then you have to execute setup wallet, which would read the private key and sets up the wallet account for you and provide you a address which is given here. I do set up wallet. Now, as I told you earlier, the Weilchain has what are called as sentinel nodes, which are a layer of indirection for external clients. Now, CLI is also a client, so I would have to connect my CLI to a sentinel node. So I'll use connect command and provide the sentinel IP, which is this, as you can see. So I'll do this and it got connected successfully. Now I'll use the deploy command to deploy my smart contract. I have already copied the path. So I'll use these path to provide the .wasm file, which is my smart contract, as well as the Vidal file. Both files you have to specify. And I'll deploy it, and it got successful. Whenever you deploy, always see whether the status is finalized or not. Okay. And only if the status is finalized, that means your deployment was successful. If you notice in the smart contract, we have this constructor which was annotated with this constructor macro. This constructor is executed on the deployment. So any initialization logic for your contract state can be put inside this, and it would be executed on deployment. So that means that for our case, this piece of code got executed successfully. Now, what I'll do is I have deployed my smart contract to a particular whale pod. We can even see which whale pod it has deployed to. It's specified here. Now, I can use the same CLI to call exposed methods of the smart contract. Exposed methods being these methods, get list and set value. So what I'll do is I'll use the execute command, the CLI, and would use the contract ID and call, let's say, get list. And I'll provide the arguments using this flag dash I, where my ID can be, let's say, okay. So right now it would return me a error saying ID Bhavya is not present in the map, which makes sense because I have not added anything. What I'll do now is I'll use the set list method we have, set list, and I'll specify the arguments. The ID would be the key I want to add, and the value can be anything, let's say 2. Set well, sorry, my bad. It's not set list, it's set well. Perfect. Now this is the mutate method. So this would have gone through the consensus protocol and would be executing on all the pod members of the whale pod. Okay. So always remember this, the difference between query and mutate method. Now it got executed. Now I can again execute get list method, and this time I will get 2 as a vector entry. I can again add bunch of values, let's say 4. Get in, I'll get the updated vector, few more values if you like. Perfect, 2, 4, and 16. And that's it. That was the complete workflow, starting with the Widal spec file, where you specify the interface of your smart contract, which it would be exposing. You do it in the language called as Widal, and it's a language agnostic file. I would even show you right now how you can generate client bindings, for example, in TypeScript, where if you are a dApp developer and you want to interact with this smart contract, you can use the same Widal compiler to generate bindings for it. And it would generate boilerplate code, including serialization, deserialization, connecting with the platform, handling errors, everything, all of that is auto-generated by the Widal compiler. So we use the Widal compiler to generate the smart contract bindings. We had initially we had an empty smart contract. We then filled in the business logic to it, which was pretty simple. We used whale collections, saying that whale collections might scale up to any number of entries, even if that means that it might not fit in memory, and how whale collections truly achieve orthogonal persistence, and the developer doesn't need to think about how the data is going to be persisted. He or she only needs to concentrate about the business logic and have a very clean mental model of considering these data structures lying in memory. So we used whale collections, implemented the smart contract, compiled the smart contract to the WASM WebAssembly target, because all the smart contracts of Weilchain are WebAssembly modules. We then used the Widal file and the WebAssembly file and used the Elliptic CLI to deploy it on chain to a particular whale pod, and then use the execute command to execute bunch of methods on it, including query and mutate method. And yeah, I think this is it for this demo. We'll go much more in detail on the whale collections and much more interesting smart contracts in future demos. Whatever I have discussed in this video is given in the official Elliptic documentation. So I'll urge all of you to check those out. We have given information about what contract state is, how it's persisted on chain, how the whale collection provides you with this lazy implementation, lightweight implementation, and achieve orthogonal persistence, and much more. So do check those out. Thanks.